Kirk math. All right, ladies and gentlemen, we are on 9.2, and we are on student companion pages 194 to 195. Our objective today is to learn how to solve quadratic equations using factoring. So we've done factoring before, and we've done factoring on quadratic equations before you really knew what they were. But now we're going to kind of put them together and use them. Okay. First vocabulary word is the zero product property. Okay. So the zero product property states that for all real numbers, A and B, as long as A times B equals 0, then, if A times B is 0, then either A or B is 0. So what it's basically saying is if I have two numbers, A and B, and I know that they equal 0, then one of these has to be 0, okay? It has to be one or the other, okay? Knowing that, we can use that information to plug into a quadratic equation, a factored quadratic equation, and solve to find those zero products, okay? So down here is our example. Here is our equation. If I set either of these products to 0 and solve, then that is the answer to this quadratic equation. Okay, so so this could be A and this is B. And so as long as one of those is 0, I know that I have a solution that this has to be correct. So if I make A equal to 0, okay, and solve, I get X is 9. If I make B equal to 0 and solve, I get X is negative 2/5. And what that means is that those are my answers. So I don't have to graph and I don't have to do our negative B over 2A. I can turn my quadratic equation into a factored product of binomials and just make each binomial 0, and the answer are the answers to my quadratic equations. Okay? So down here, it shows again, we're going to double check our work. So after we do this, we're just going to check and make sure that that's true. So they replaced 9 into the into the full equation. That was one of our options, and solved, and they got 0. Then they replaced negative 2/5 into the equation, and they got 0. So both of these answers are correct, which means that our solutions, or our x-intercepts, are 9 and negative 2/5. Here is where we're going to try it on our own. So you guys are going to do B, we're going to do A. So basically we know that as long as one of these two binomials is 0, then our equation can be true. So I'm going to do two problems. I'm going to make one problem where 2x minus 1 is equal to 0, and I'll do another problem where x plus 3 is equal to 0. Okay? And now I solve. So my one possible solution is 1/2. And then over here, I'm going to subtract, 3 from both sides. And I'm going to get x is equal to negative 3. So my solutions here should be 1/2 and negative 3. So what you're going to do now is do the same thing for the B over here. Go ahead and solve using the zero product property. Now here on example 2, we're going to solve by factoring. So we're going to take the information we had on the previous one and we're going to put it together here. So it says, how can you use factoring to solve this product or problem right here? The standard form of a quadratic equation, which is a times x squared plus bx plus c equals 0, where a is never 0, that's what we want. This is the formula. So we want to always put it into that. So kind of the first thing that we're going to do is turn this into this standard formula. So we know that this is a x squared. We know this is b times x. And what's over here on the other side of my equal sign is actually the opposite of c. So all I have to do is move C back over to the other side using inverse operations, and I have standard form. So what I'm going to do is just add 20 to both sides, and I'm going to get x squared plus 9x plus 20 equals 0. And now we have a quadratic equation, okay? So here's our quadratic equation. That was step 1, write the equation in standard form. Step 2, make a table to find the set of factors to solve. So if you remember from when we were doing factors, I'm looking for a number whose product make 20, but its sum makes 9. So when I multiply them together, I get 20, but when I add them, it needs to make 9. So the two numbers that have that product of 20 and sum of 9 are 4 and 5. So we're going to take the 4 and the 5, and those now become the two pieces in my factored binomial, right? So it says rewrite the standard form of the equation in factored form. Okay, so my 4 becomes what I add here, and my 5 becomes what I add here. Okay, and now I'm going to use the zero product property to solve and find my answer. So now that I have a factored form of my quadratic equation, I can now set each of my factors to 0 and solve to get my answer. So the answers here are -4 and -5. So let's try one together. So the first thing I'm doing is writing my equation in standard form. My equation is already in standard form, so we're done. I now need to find the factors of C, okay, that when added together make B. Okay, so what are the factors of 64 that when added together make 16? So these are all the factors of 64. The two factors that when added together make 16 are going to be 8 and 8. So those are going to be my two numbers that I'm going to use to write in factored form, which is the product of two binomials. So I'm going to have x here and an x here, and I'm going to use these two numbers. So it's going to be x plus 8 times x plus 8. I'm now going to use my zero product property to solve. So I'm going to make x plus 8 equal to 0. X is -8, and it just so happens that both of these products are the same. So my answer is just -8. I only have one solution in this problem, and it's -8. So now it's your turn. Go ahead and use our steps right here, doop, 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 to solve this quadratic equation and find the x-intercepts or our solutions. Okay, on example 3, we are using a real-world word problem. Okay, we have a museum vault that has an outer steel wall with a uniform width of x. A hint, this is very similar to our like picture frame or pool deck problems. Okay, so all around this is x. The area of the museum vault ceiling and the outer steel wall is 1,664 feet squared. What is the width of the outer steel wall? So we already know that if I take the area of the ceiling and the outer steel wall, if I take the whole entire shape, I already know the area of that is 166.4 feet squared. We want to know the width of the steel wall. Okay, the width here, we know this is x on all sides. This is 20 and this is 40. But we don't know what this is, and I don't know what this is. This is the piece that I need to know. So the first thing they do is write an equation to represent the area of the vault. And this is just like those picture problems, guys. I am going to take the 40, which is my length, and I'm going to add the two w's to it. So I get 2x plus 40. Then I'm going to take 20, which is my width of the inside of the vault, and I'm going to add the two x's to it, and that's how I get 2x plus 20, length times width. I know that the total area is 1,664. So I'm going to set that here. And now I am going to FOIL or use distributive property. And that is how they are getting 4x squared plus 120x minus this number here is coming because notice that they moved the 1,664 to the other side of my equal sign. Okay, so the step they don't show you is that 20 times 40 is 800. Take away the 1,664, and I'm left with the negative 864. Okay. Now what they're doing is dividing 4 just to simplify. You can use the big numbers, but 864 is not nice. And we would prefer an x without a coefficient. So because all of these numbers are divisible by 4, that's what we're going to do, is divide everything by 4. And that's just something that you learn by looking at your equation and asking yourself, do these numbers all have something in common? Can I reduce or divide in order to make it easier for me? Okay, so once they divided, they got an easier equation to work with. And because they're going to go ahead and factor this out. So they're looking at numbers that multiply to make 216, but when added together, or make negative 216, but when added together, make 30. So they got negative 6 and 36. And so what we found out is that the two solutions are negative 6 and negative 36. However, we are looking at the width of a wall. Can the width of a wall be negative 36 feet wide? No. So this solution here is not reasonable because we're dealing with a real world situation. So the width of the wall has to be 6 feet. So they substituted it in and checked to see if they're right, and they are. So on this problem here, you're going to do the same thing. You need to write an equation and then solve for the solutions, and then look at your solutions and see which one is reasonable for this specific real world problem. Go ahead and pause the video and give it a try. I'm going to give you the first equation just to see if you're on the right track. So here is the length and width of my picture plus frame. Here is the total area. See if you can go ahead and FOIL, write in standard form, solve using the zeros. Okay, example 4 is pulling a factored form of the quadratic equation out and writing it. So we're looking at something with a graph, okay? So it says, how can you use the factoring to graph the function? So we take our formula here and we turn it into our factored equation. That's step 1. And then we determine our two solutions. So we know that this is, remember, this is our x-intercept. So this is negative 2, 0 on a graph, and this is 4, 0 on a graph. In order to find our vertex, remember that a parabola is symmetrical, so the vertex will be halfway between these two y-intercepts. So because it is halfway between my two x-intercepts, I'm going to find the average of the x-intercepts to find the coordinates of the vertex. So they added the 4, which was the x-intercept, and the negative 2, and divided by 2 to find an average or a mean, and they get 1. So we know that halfway between is 1. That's the x coordinate of the vertex, 1. Then we plug it back into our equation to find y, and we get our vertex is 1, negative 9. The last step is then just to plot. Okay, so now you're going to try, and remember these are your steps right here. Okay, so factor the related quadratic equation. So you need to turn this into something with x and y equals 0, or sorry, the two x's multiplied together equals 0. Then determine the solutions using that zero product property. Set your two items equal to 0, whatever they are. And then you're going to find that vertex by finding the average of the x-intercepts. So you take this plus whatever your two x-intercepts are, divide by 2, and that's going to be your x-coordinate. Plug it back in, and you'll get y, and then sketch a graph. All right, so this last part I'm probably going to have to do on a second video. It's our last example, but it does take a bit of time. So make sure you have the problems from the previous examples, and then we're going to start back up on, I believe, example 5. Let me see. Yep. On example 5, the next video will be super short. I apologize.